हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार। फ्रेंड्स, आइए स्टार्ट करते हैं दिस टॉपिक, दिस क्वेश्चन रिलेटेड टू बेल कोलमैन साइकिल। फ्रेंड्स, क्वेश्चन इज a refrigerator working on Bell Coleman cycle operates between pressure limit of 1.05 bar and 8.5 bar. Air is drawn from the cold chamber at 10 degrees centigrade. Air coming out of the compressor is cooled to 30 degrees centigrade before entering the expansion cylinder. Okay. Expansion and compression follow the law PV to the power 1.35 equal to constant. Determine COP of the system. Take gamma equal to 1.4 and Cp equal to 1 kilojoule per kg Kelvin for air. Friends, the data has given here. Let's understand the question and let's understand the question, then we will solve this one. Friends, it is saying that this is the Bell Coleman cycle on PV diagram, pressure versus volume diagram. Friends, the process 1 to 2 is the process in the compressor. It is following PV to the power 1.35 is equal to constant, because here it has given the compression and expansion follow this PV to the power 1.35 is equal to constant. So this is the compression process, okay, in the compressor. Then it will pass through the cooler, okay, where heat reaction will take place at constant pressure. Getting friends? So process 2 to 3 is the process in the cooler. Then it will pass through the expander or expansion cylinder. This is also following the law PV to the power 1.35 is equal to constant. Then it will pass through the refrigerator, where it will gain gain the heat, or it will absorb heat in this process. This is also constant pressure process. Okay. Now the data has given here. Here it is working between the pressure limit of 1.05 bar and 8.5 bar. It means the pressure P1 is at 1.05 bar. Since P1 equal to P4, so P1 equal to P4 equal to 1.05 bar. Okay, and at P2 equal to 8.5 bar. It means this pressure P2 equal to P3 equal to 8.5 bar. Okay. Now the air is drawn from the cold chamber at 10 degrees centigrade. This is the cold chamber. So it is drawn. It means for compression purpose, the air is drawn from the cold chamber. Okay. So this temperature it has given at temperature at point 1 is given 10 degrees centigrade. So what we will take, the temperature in the Kelvin format we will take. Okay, it is given 10 degrees centigrade, so this is 10 degrees centigrade, but what we will take in the Kelvin scale. Absolute temperature we will take. Okay friends, so here temperature is equal to 283 Kelvin. Then air coming out of the compressor is cooled to 30 degrees centigrade before entering the expansion cylinder. So friends, here you see this is the expansion cylinder and this is the cooler after compression. So air is cooled up to 30 degrees centigrade before entering the expansion cylinder. So this is the expansion cylinder and this point is the entering in the expansion cylinder. Okay, so here 30 degrees centigrade, it means T3 equal to T3 equal to 273 plus 30 is equal to 303 Kelvin. Getting friends? So temperature at this point and temperature at this point has given, and the pressure P1 equal to P4 equal to value has given, and P2 equal to P3 equal to some value has given. Okay, and the law which is followed by compression expansion, it has also given. Getting friends? And one more point is there, gamma value has given 1.4 and Cp value is equal to 1 kilojoule per kg Kelvin of air, it has given. Okay friends, so friends, let's solve this question. First we will understand what we have to find, what is to be determined. COP of the system is going to be determined. Okay, first we will understand how can we find the COP, or what is the formula of COP. Okay, COP equal to refrigeration effect upon work input. Okay, or refrigeration capacity upon power input. Getting? Refrigeration effect equal to heat extracted from the process 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 4 to 1. Okay, refrigeration effect is equal to heat extracted by this process, or you can say heat addition by this process 4 to 1. It means QA is the refrigeration effect. And what is the work input? What is the work input friends? Input equal to work done by the compressor and work done by the expander. So we will find net work done. Net work done equal to 1, 2, 3, 4. 1 is the net work done. Okay. Why? Because see here, this is the work done by the compressor. This is the work done by the compressor, and this is the work done by the expander. So net work done we should find. So 1, 2, 3, 4, 1. This will give the net work done. Okay. So net work done equal to how much friends? Net work done, W in net equal to work done in compressor minus work done in expander. Since it is follow PV to the power 1.35 equal to constant, so it is not a isentropic process. It is following polytropic process. Polytropic process. Okay, so in this case friends, work done is equal to how much? This n upon n minus 1. This index n equal to 1.35. This value, so the index value, polytropic index n. Here R into temperature at 2 minus temperature at 1 for compressor work, T1 minus n upon n minus 1 into R for expansion process, temperature at T3 minus temperature at T4, temperature at T3 minus temperature at T4, where in this process n is the polytropic index 1.35 and R is the gas constant of air. Okay, so how can you find this one? How can you find gas constant? This Cp minus Cv is equal to R. Okay, and Cp by Cv is equal to gamma. Getting friends? So here the value has given, first we will find the value here. So here gamma value has given 1.4 and a Cp value has given 1. So from here this Cp by Cv is equal to gamma. So Cv is equal to how much? 1 by 1.4 it will come, because gamma equal to 1.4 and Cp equal to 1. So Cv equal to 1 upon 1.4. it will come. So from here friends, R value equal to how much? 1 minus 1.4 equal to R. So R equal to how much? 1 minus 1 divided by 1.4. So it will give friends 0.287 kilojoule per kg Kelvin it will give. Okay. So here R is the gas constant for air we find it, and the W net equal to what is the formula? N upon N minus 1 R T2 minus T1. This is the work done in the compressor and this is the work done in the expansion. So if you minus this one, then we will give the net work done by the system. Okay. So we have to find two things. First, we have to find the heat absorbed and then we have to find work input. So if we divide this one, then we can get the COP. This is the concept. Okay, friends. And here no doubt should be there. N is the 1.35 and R is the gas constant. The value of R equal to 0.287. Okay. Now we will find the temperature at each and every point. We will find temperature at each and every point. Why? Because here you see friends, net work done will give this T2 minus T1 and T3 minus T4. So this is T1, this is T2, this is T3 and this is T4. We know only this T1 value and we know value here T3 value. But we don't know what is the value of T2 and we don't know what is the value of T4. Okay. After solving, we will find this value. So let's solve this question. Okay, friends. Now we will find friends, from here you see the process. We will find by this process this C here, this is the isentropic process and this is also a isentropic process. So process 1 to 2, it is the what? Pb to the power 1.35 is equal to constant in compressor. Okay, friends. So we know that friends, the relation between T2 by T1 equal to P2 by P1 to the power n minus 1 upon n from thermodynamic relation of polytropic process. Okay. So the relation between T2 upon T1 is equal to P2 upon P1 to the power n minus 1 upon n. And we know the value of P2 8 bar and we know the value of P1 how much? 1.05 bar to the power n value is equal to how much? 1.35 minus 1 upon 1.35. Okay. So bar to bar cancel out. So how much pressure is there? 8 upon 8 divided by 1.05. Okay. So it will come this much and to the power 1.35 minus 1 is equal to 0.35. So 0.35 divided by 1.35, it will give friends the value equal to 1.6929. Okay. So T2 by T1. T1 we know that the value 283 equal to this one. So T2 equal to how much friends? T2 equal to, we will multiply with 283. So we are going to get sorry, one mistake has done by us. Here temperature pressure is equal to 8.5 bar. I am taking only 8 bar. For sorry for this mistake, just take this pressure 8.5 bar, 8.5 bar. Okay, so here mistake is there, please correct it. I am sorry for the mistake. So we will calculate again. 8.5 divided by 1.05, 8.5 divided by 1.05, so its value will come this one to the power 0.35 divided by 1.35. So friends, it will come 1.7197, and the T2 value is equal to 283. So friends, it will give 486.69 Kelvin. Okay, so it will give T2 value will come 486.69 Kelvin. Okay, now similarly we will find the value of T4 from process 3 to 4, since it is also follow the process Pb to the power 1.35 is equal to constant in expander. Okay, so this T3 by T4 equal to P3 by P4 to the power n minus 1 upon n. And we know that friends, P3 is equal to 8.5 bar and P4 is equal to 1.05 bar. So from here friends, again the same value will come. Okay, again the same value, getting friends, both are same, so it will give same value 97. So here T3 value is equal to how much? T3 value is equal to 303 Kelvin. So here this 303 divided by T4. So from here friends, the T4 value equal to 303 divided by 1.7197. It will give friends how much? This 303 divided by 1.9, sorry, 1.7197. So friends, the value is equal to 176.19 Kelvin. Okay, so the T4 temperature is equal to 176.19 Kelvin. So all temperature we got. Okay, now we will find the refrigeration effect equal to heat addition equal to how much? This is at constant pressure. So for this we will take this temperature Cp. Cp is equal to 1. Cp is equal to 1 kilojoule per kg Kelvin we will take. Okay, so Cp into temperature at T1 minus temperature at T4. Getting friends? Okay, so for here it is at constant pressure, so we will take Cp equal to 1, this value, and T1 we know that this one, T2, T4 we know that this one. So what is the value of heat absorption? Equal to 283 minus 176.19 Kelvin. So friends, it will give how much? It will give friends 176.19. So 283 minus answer, it will give 106.806. Okay, so this is the heat addition in kilojoule per kg. How? Because the Cp unit is equal to kilojoule per kg into Kelvin into temperature is in Kelvin. So Kelvin to Kelvin cancel out, kilojoule per kg it will come. Getting friends? So this is the heat absorption or refrigeration effect. Okay. Now we will find the work input, net work input equal to n upon n minus 1 or this T2 minus T1 minus n upon n minus 1 into R T3 minus T4. Okay. Don't be confused friends, this much big formula. The simple concept is that this equal to enthalpy at point 2 minus enthalpy at point 1. This will give the work input in the compressor minus enthalpy at point 3 minus enthalpy at point 4. This T3 minus, sorry, S3 minus S4 will give the work done in the compressor. So this is the work done in the compressor and this is the work done in the expander. We know that this enthalpy is equal to C into T, and here since it is not a isentropic process, so this C value equal to will take how much? Gamma, sorry, n R upon n minus 1. So this, here you see this C into T2 minus T1 minus C into this T3 minus T4, and the C value is equal to nR upon n minus 1. That's why this formula has come. Okay. So just remember this one. Okay. So let's find the value of W net. This is 1.35 divided by 1.35 minus 1, and R value is equal to how much? R value equal to how much friends? This 0.287. T2 equal to T2 is equal to how much? T2 equal to how much? 486.69. T1 is equal to 283 minus 1.35. 1.35 minus 1 into this term is same 0.287 in bracket temperature at T3 minus temperature at T4. So 303 minus 176.19. Okay. So this is the work input net. So friends, we can find the value here. How much it will come? So this term is same in both the case. Okay. So 1.35 divided by 0.35 into 0.287. So what we will do? 1.107 will take common from this point and this point. So this is the common, and this value is equal to how much? 486.69 minus 283. So it will give how much? 203.69. So this value is equal to this one minus this value is equal to how much? 303 minus 176.19. So friends, it will give how much? 126.81. Okay. So from here the work input net equal to how much? Friends? This 126.81, like 203.69 minus answer into 1.107. So friends, it will give approx 85.106 kilojoule per kg. Okay. So we are able to find here this refrigeration effect 106.806 kilojoule. And what is the work input? This is the work input. So what is the COP friends? COP is equal to heat addition upon work input net. In this case we will find the net work input. So from here 106.806 divide by 85.106. So how much it will give? This 85.106. So 106.806 divided by answer. So friends, this is the result. 1.2549 is the COP. This is the answer. Okay. So concept, just understand how to find. Okay friends. Since, or we can say, at any point friends you are getting doubt, you just ask me in the comment box. I will try to explain again. Okay friends, so if you like my video, then like my channel friends, like my video, subscribe my channel, and share to your friends. Thank you.